Okay, I'm going to go over just a few geometry questions that I think will help you in preparation for the HSPA. I'm going to start with the multiple choice, and as always, I'll make this file available to you for download in addition to the video. So that way, if you want to look at these problems slower, read them out, etc., take notes on them, I will provide you with the work. You might want to open that up so that way you can follow along. That's kind of up to you. Okay, you've got the measures of two supplementary angles are in the ratio 4 to 5. So all of a sudden we've got two very important pieces of information here. Two supplementary angles and the ratio 4 to 5. What is the degree measure of the smaller angle? First of all, this idea of supplementary. Supplementary means that it is 180 degrees sum. Okay? Ratio. Whenever I'm dealing with a ratio and I want to know which piece is the smaller and the bigger, what I need to do is figure out what each piece of my ratio is actually worth. The way I do that is I decide how is it divided up. 4 plus 5, so I'm going to add my two pieces of ratio to say that 4 to 5 is actually going to split into 9 pieces. I take my 180 degrees because that is supplementary and divide by each piece. That's 20 degrees. That means 20 degrees is now worth each piece of my ratio. The smaller angle is the smaller number 4. That means I want 4 pieces of 20 degrees. 4 20 degrees is multiplication, and it is 80 degrees, which is B. Again, ratio problems always work the same way. I take the sum of my ratio and divide into what I want to get the piece, then take the piece and multiply times the part of the ratio that I want. Okay, next question. In which of the following diagrams are angle A and angle B vertical angles? Now, vertical angles are angles that are made by two intersecting lines, and then the angles that they form are actually congruent. So this angle would equal this angle would equal this, and these are vertical lines because they are formed using the same lines, which means what you need to do is decide whether or not angle A and B are formed using the same lines. I used to trace them. Here's a straight line. Oops, that doesn't look good at all. Let's try that again. Here is your straight line forming part of A, and if you'll notice it also forms B. So then I do again a straight line forming B and part of A. These are formed by two intersecting lines that are nice and straight, which means I is absolutely an option for a vertical angle. If you'll notice and you check your answer choices, all of them give the option I. So that is the obvious one. Okay? All right, let's try the second one. I'm going to look at B. This is one of the lines the angle creates for B. Is A on this line at all? You should notice it's not. It's actually on these two lines. The angle that's actually vertical angle to B is this one over here, because this is the one that shares the two lines. You'll notice A only shares this one. It does not share this one. So now you know that 2 is not a vertical angle. So I'm going to go to B, and I'm going to cross it out because Roman numeral 2 is not an option. I'm also going to go to D and cross it out because Roman numeral 2, again, is not an option. Now, at this point, even if I wasn't sure about 3, I'd have a 50-50 shot of guessing correct. So, something to think about. Of course, I want the whole credit, so I'm going to check this one. You should notice if I try to make A, I would have to intersect B. Everyone kind of see that? You'd go through the angle. Again, that's not a vertical angle, and in fact, A doesn't have a vertical angle, and neither does B. So 3 is not an option, which is why the answer is A. Okay, take a look at the next one. Which of the following statements is always true? Okay, always true. That word's kind of tricky. Always true. All you need to do is figure out whether or not it's possible for this to be a false statement. So you're looking for one possible way to make it false. Vertical angles are supplementary. Well, we just talked about vertical angles. Okay? And the fun thing about vertical angles is that they are equal to each other. So if that's 1 and that's 2, it would mean angle 1 equals angle 2. Now, supplementary means that the two angles add up to 180. So that means angle 1 plus angle 2 would have to be 180 for these two to be supplementary. Now, that's entirely possible. It could be 90 degrees and 90 degrees. However, if angle 1 was 80 degrees, this relationship would say that angle 2 is also 80 degrees. And I'm sure you can see that 80 plus 80 is not 180. So that just won't work. Okay, so let me get rid of that. That means A is not an option. Okay, A is not an option. So I'm going to go and I'm going to cross out A because that is not an option. Now, the complement of an obtuse angle is acute. Okay, first of all, that word complement. Complement means the angles add to 90 degrees, right? Obtuse is a word that means the angle is larger than 90 degrees. Okay, as I'm sure you can tell, angle cannot be larger than 90 and yet add to be exactly 90 degrees. It's just not possible. So B is once again out of the loop. The supplement of an obtuse angle is acute. Well, supplement means adds to 180. Now, an obtuse angle just has to be bigger than 90, but it should be smaller than 180. So this one gives me hope. Because if I draw an obtuse angle, right, that's definitely more than 90, you should notice that this is a tiny little angle over here. I like to call it a cute little angle. It's a cute little angle. It's acute. That looks plausible. So C is looking like a good answer. You still want to check D and see if you can prove that it's true, or not true, I should say. Complementary angles are congruent. Complementary means that the two angles add up to 90. And for congruency, it would have to be 1 equals 2. Now, if I picked 45, that would actually hold true for both of these. However, just like our first problem with those vertical angles, if I pick something like 40 plus 50, they're still complementary, but 40 does not equal 50, so they are not congruent. Which means the only problem that is always true is C. Okay, this next question, if D is the midpoint of AC, I would immediately draw that out. You've got a line A, C, and we're going to pretend that's a nice pretty straight line. The midpoint is D. Okay. And now this is A and C. Now it turns out this letter C is the midpoint of A, B. Now midpoint just means it's directly in the middle. So that means this piece over here has an entire same length as this piece did. Now, I'm looking for the entire length. What is the length of AB? So this entire piece. If BD, this piece right here, is 12. Okay, BD is 12. Now, here's kind of the interesting thing. D is the midpoint between B and C. Then C and B is the same distance between A and C, because C is the midpoint, right? That means there's a point over here, let's call him D, that is the midpoint of CB. He's kind of the opposite of D over here, okay? That means this 12 is composed of 3 equal segments. I'm going to take my 12, I'm going to break it into the 3 equal segments, and that tells me all my segments are equal. And again, that's because I have a midpoint here. They didn't tell me in the problem, but if I assign it, I'm pretty sure I can see the 3 4s. Now, since D is the midpoint of AC, that means this piece and this piece are congruent, at which point you should be able to tell that this has been divided into 4 slices, all worth 4 points, which makes this a total of 16. Okay, so which of the following sets of lengths does not represent a triangle? Now, a triangle. Okay, easiest way to figure these things out is the sum of the 2 smaller legs should be greater than the 3rd leg. Okay, so in A, they're all the same leg. Technically in a triangle, that means it's a equilateral triangle, so that's absolutely going to exist. But just for proof, I'm going to say leg 1 and the second leg is 2. 2 is indeed bigger than the 3rd, so he is a triangle. Let's look at B. I'm going to take the 2 smaller sides, 3 plus 4, it's 7, and then is 7 greater, those both look the same, let's try that again, 7 greater than 5? The answer is absolutely. So B is a triangle, which means it is not a knot. Let's look at C. 2 smaller sides, 8. Is 8 greater than 8? It's not greater than 8, it's equal to 8. That makes me think C is my answer. However, just because it takes a second, try D. I'm going to take my 2 shorter, 5 and 12, add them together, that is 17, and find out if it is larger than the 3rd side. 17 is in fact greater than 13, so D is also a triangle, which means C, the one that was equal, is the only one that is not representing a triangle. Okay. Now let's talk about triangles for a second. If the measure of one angle of the triangle, measure of one angle of my triangle is equal to the sum of the other 2 of my triangle, which means, this is not exactly the best graph, then the triangle is always, well, one angle is equal to the sum of the other 2 angles, okay? That means these 2 numbers are equal to each other. In 180 degrees, for the 2 numbers to be equal, one by itself and one as a sum, they'd both have to be 90. So angle 1 would be 90, and then angle 2 plus angle 3 would have to be 90, because that's the only way to equal out these 2 sums. Okay, So the only time that the measure of one angle of a triangle is equal to the sum of the measures of the other two is when it is right. All right, which of the following cannot exist? An isosceles right triangle. Here's that it cannot exist question again. What you're trying to do is prove whether or not it exists or not. This says isosceles right triangle. Right triangle means 90 degrees again. Okay, and that means this angle and this angle have to be exactly the same and equal 90. Now, the reason it has to equal 90 is because the angle, sum of the angles in a triangle is 180 minus the 90 we've already used as the right triangle is 90 degrees left over. So now these two angles, x plus x, has to equal 90, which means 2x has to equal 90, which means x should be 45. And that would mean 45, 45. I have a 45, 45, 90 triangle. That is, in fact, isosceles, because isosceles means angles are equal because their corresponding sides are equal. Okay. Now, isosceles obtuse triangle just means that one of these angles is huge, bigger than 90. Let's say it's 120, just to make it up. Because again, we're just trying to prove whether or not these are true or not. 180 is my option. I take away the 120. It means I have 60 degrees left to play with. Isosceles means sides are equal, which means corresponding angles are equal. Can I think of two numbers that are the same that add up to 60? The answer is absolutely. 30 and 30. So that would be this one. Scalene right triangle. Scalene means that none of the sides are equal, which means none of the angles are equal. So, random triangle. It is a right triangle, so I know 90 degrees is taken out. So what I need to do is figure out the other 90. As long as I can split this into two numbers that equal 90 and aren't equal to each other, this absolutely can exist. That brings me to D. Now, obtuse right triangle. An obtuse triangle has an angle larger than 90 in it, but a right triangle has an angle of 90. So again, if I'm looking at a right triangle, I know 90 degrees is already taken up. That means there's 90 left. Obtuse would have to be an angle even bigger than 90, which is not possible. So I would pick D. Okay. That's going to conclude part 1 of this video.